Good evening, everyone. This is Bharata Reddy. This is my OS DA3. It is about converting of NAND to Tetris, and here it goes. So, sequential logic. Basically, what is sequential logic? Sequential logic is a type of logic in which output is dependent on previous inputs and also on previous outputs. It works in the form of clock cycles. In sequential logic, the hardware should have a memory to store the previous data. Basically, it analyzes the previous data, basically the inputs and the outputs of the previous data, and it performs sequential logic. The clock. Clock cycle works in the form of unit of time. Each input will be reflected in output and changes every clock cycle. The output doesn't change instantaneously, but will change over a short period of time. This is the basic example of the clock, and this is the time taken according to the clock cycle, right? Combination and sequential logic. Combination logic is a type of digital circuit where output is determined directly by combination of current inputs, and it doesn't depend on the previous inputs or outputs. Sequential logic. It is a type of digital circuit where output is dependent on previous and previous outputs and inputs. Use it to process data in a specific order. So basically, the difference between them is in combination logic. It doesn't depend on the previous inputs or outputs, whereas in the sequential logic, it depends on the previous inputs and outputs. These are two examples. So in the first case, in combination, output of t is equals to function of integer t, and sequential output of t is equals to function of input of t minus 1. And yeah, and it follows the same in the second one also. These two are the examples. Flip-flop. In digital circuit, flip-flops are a type of circuit element that can store one bit of data. They are used to store and transfer data between logic circuits and memory. Flip-flops are a type of clock circuits, meaning that they need an external signal called clock to control where they store data and transfer data. Flip-flops are essential part of modern digital circuits and are used in everything from computers to communication. These are four types of flip-flops: set or reset type, JK type, D type, and toggle type. Yeah, D flip-flop. D flip-flop, yeah, D flip-flop. A D flip-flop is a type of flip-flop that store one bit of data. This type of flip-flop is often used to store the current state of a digital circuit. A D flip-flop has two inputs, D and a clock. When the clock signal is high, the data at the D input is stored in the flip-flop. When the clock signal is low, the data stored in the flip-flop is unchanged. So basically, when the clock signal is high, the data is stored in the data at the D input is stored in the flip-flop, and when it is low, it remains unchanged. Remember, the input of the clock signal and it gives it to the next clock. Okay. The first clock cycle, there won't be any output as well as don't know what happened previously. So this is the formula of D flip-flop. This is the symbol representation of D flip-flop, and this is the truth table. So when it's 0, 0, it becomes Q and Q dash. 0 and 1, Q and Q dash. When it becomes 1 and 0, it becomes 0 and 1. 1, 1, it becomes 1, 0. It's a truth table and the symbol representation. 1 bit resistor. A 1 bit resistor stores 1 bit value in its unit. It refreshes. Okay. This is basically the 1 bit resistor and the load input output. Uh, Von Neumann architecture. The von Neumann architecture, sometimes referred as a von Neumann model, is a type of computer architecture that is based on design of first computers developed by John von Neumann. The von Neumann architecture is based on the idea of many single memory that both stores data and instructions as well as certain process unit CPU that can execute instructions and process data. This type of architecture is widely used in modern computers, although there are some variations. This is the diagrammatic representation of one-linear architecture. So basically, the input it communicates with the memory. The memory exchanges with the CPU, like gives some inputs and get back some outputs. The ALU and the control part, it's all present in the CPU part. And at last, it produces the output. This is a computer system based on one human architecture. Okay. RAM unit. What is RAM? Random access memory. Random access memory is a type of computer memory that allows the processor to read, form, and write it at any time. RAM is used to store data and instructions that the processor is currently using, and it stores data that has been recently used. RAM consists of n registers stacked together, and only one of them is used based on load and in value. To read from RAM, the address is set to the register address and data is outputted. To write RAM, the address is set to register address, the load is set to 1, and the input value is inputted. The value is then outputted from the next cycle. That's all about RAM units. And at last, counters. Counters are used to keep track of set of instructions and check which instruction to be executed based on the count. A counter PC is used to realize which PC is equals to 0. So when it's 0, it is in the reset value. When PC plus plus is given, it goes to the next instruction. PC is equals to n, it goes to the nth instruction, where n can be anything, like based on the number of instructions. This is a diagrammatic representation of counter. Yeah, let's go to the stimulation part. Yeah. First, you open up your hardware simulator and load the chip. We'll load RAM 64 scale, yeah. Yeah, now we can see the chip is loaded. So basically, let's give the input. Give the input as some 65 and load address. Load would be just 0 or 1. We'll give 0. And the address, let's put for example 10. And we press enter. Now we run. Okay. Well, let's give some less value. Let's pick the same one. Yeah. You can see at the 10th place, the 15 has been stored. The time taken is plus 2. Like we ran this thing 2 times. We can change the address values and we can store the memory in the different places based on our required address. We'll change the input as 25. Give the address as 12. Pointer. We'll just save it and run it. Yeah, you can see here in the 12th place, 25 has been stored. And load value, we can take only 0 or 1. Let's check one. Yeah, you cannot take more. It's just 0 or 1. Okay, electronic. We got in the 12th place, we got it 25. And this is how it's being done, the simulation. Thank you.